Well, good morning. This is Algebra, and this is the day we are all home because people are sick. I emailed you this worksheet called Linear Equation Word Problems Part 2. All linear equations, when you're talking about word problems, and unfortunately we have not had a chance to just chat and have you talk back with me on what your confusions are, but I'll tell you what works really well is that if you can follow a pattern, a step of things to do, you'll get really good at this. And if you don't follow the pattern, you will be just wondering most of the time, what do I do? What do I do? I don't know where to start. Here's the 5 steps. You write down what you know, you write an equation that shows relationships that are described in the problem. You simplify the equation to have only one variable. You solve for that variable, and then you substitute back into the other relationship you wrote back in number 2 here to figure out what the person is asking. Sometimes they'll give you more information than you need to know. They'll ask for, they want Bob, Sally, and Joe's age in the problem, but really the question is something like, how much older is Bob than Sally? So you have to always go back to the original question at the end and figure out what it is you're supposed to solve. But what I've done, and I printed this out, or not printed this out, well, I printed it out here, but I emailed you 12 questions. And if you don't get the email, I'm holding this up in front of you so that you can look at them in the video. And then there's a couple more here. So there are 12 problems. That's going to be your homework this week, is to go through these. And you're going to do all 5 steps. So I'm going to go through these with you now. This is now me answering to see, did you do them right? And what I hopefully expect to see you have when you come back to class next time we meet. So linear word equation problems, part 2. Okay, so let's start with the first question. I'm going to arrange this a little bit, and let's see what we've got here. All right, the question is, Mariel has some money. Deke, yes, I had a friend named Deke. His name was Deke Gunderson. His dad taught my basketball thing, so that was fun. Anyway, so Mariel has some money, and Deke has $3 more than Mariel because Deke's dad always used to say, neither a lender nor a borrower be. And so whenever I tried to borrow money from Deke, he would quote his dad. And so Deke never lent me money. And I knew him for several years. Not that I'm bitter or anything, but there are many times that I would have been able to go to the movies if Deke had lent me the money. And I didn't get to go because, sorry, back to the equation. So Mariel has some money. Deke has $3 more than Mariel. Together they have $11. How many dollars does Mariel have? So your brain says, I don't know what to do. And so what you do is, again, following these 5 steps, write down what you know, write an equation that shows the relationships described in the problem, simplify the equation, solve for the variable, substitute back. Seems like a lot of work, but trust me, it is not. So here's how you would do this thing. So you write down what we know. We know that Mariel has some money. So I'm going to say, let M equal the money for Mariel. So I actually would write this down. I don't care if I was in college or not. I would, especially because there are oftentimes you would have equations, not just linear equations, but equations with 7, 8, 9, 10 different things going on at a time. So I would get lost if I didn't make a little chart. So M is Mariel's money. Deke is going to be the said by the letter D. So when I go and I write my equations, I've always got this little handy chart right here. So that's writing what I know. I know M is Mariel and Deke is Deke's money. The question is, Mariel has some money. Deke has $3 more than Mariel. Okay, so now I see a relationship between Mariel's money and Deke's money. This is part 2. Write an equation. Well, I know that Mariel's money and Deke's money are not the same. The amount of Mariel has is not the same as what Deke has. So I kind of write M and I leave a little bit of space, and then I write equal and I leave a little space in D. And then I just kind of go back over the question. It says Deke has $3 more than Mariel. So I think about it. And so let's see, who's richer, Mariel or Deke? Deke is richer. Okay. So Mariel, if you add $3 to hers, they would be equal. Now that's my equation. I left space so I could write it in the left or the right. I could have done that. Another way to have written that is I could have said, okay, Mariel, Deke, and said, okay, who has more money? And it's Deke does. So if I subtract 3 from Deke, I get the same as Mariel. So I either have this equation or this equation. I don't need them both. I'm just going to pick one. I picked the one I did the first. Both are the same. So now I've done equation or part number 2. I write an equation. This shows the relationship. Mariel has some money. Deke has $3 more. Together they have $12. Ooh, another relationship. So if I take Mariel's and Deke's together, they have $11. Okay, so this is my second relationship. So I have a couple of relationships. These are mathematical equations, which are just simply relationships. So now I go to the fourth one, or the third one, is I simplify the equation to have only one variable. Again, what am I saying? I'm going to slide this down here so you can see it. 1, write down what you know, assign letters. Did that. Okay, next, write an equation that shows relationships. Well, I have 2 equations. Number 3, simplify the equation to have only one variable. Okay, so this is what I'm doing next, is that if I know Deke is equal to 3 plus m, I could rewrite this one. Instead of saying m plus Deke, I could substitute, instead of D, 3 plus m. See, that's D. So I'm saying m plus D equals 11. See how that gets rid of one of the variables? So now I am going back to a very simple algebra problem that we've been doing for months now. So I have m plus m is 2m plus 3 equal 11. Subtract 3 from both sides. 2m equals 8. Divide both sides by 2. M equals 4. So now I know that Mariel is 4. I can figure out Deke because 4 plus 3 is going to be 7. And I know Mariel plus Deke is 11. 4 plus 7 is 11. And Deke is 3 more than Mariel. So I've done everything I could. Now I go back to the original equation, though, and I say, okay, what's the question? The question is, how many dollars does Mariel have? Oh, the answer, she has $4. So she has $4. So I don't really know what the answer is to the question until I go back to the question and see what it's asking. This question doesn't really even ask what Deke has. So that's always why you have to do step 5. Okay, so that's how we do this. So I'm going to go through all of these questions. You're going to have to kind of bear with me here as I go through them and see how we go. Okay, I'll try and go through them fast so that I don't take up a lot of video time. Don't be watching this video until you get to the end. If you get lost, just slow down, back up, and make sure you know where you lose me when we come to class next time. All right, question number 2. The perimeter of an isosceles triangle is 24 centimeters. An unequal side is twice as long as the equal sides. How long are each equal side? First thing you got to know is what's an isosceles triangle. Look it up in a dictionary if you don't know. That's where 2 sides are the same and then a third side is different. So it can be tall and skinny. It can be fat and wide. I've just kind of wrote a generic one. I'm going to label each side of this triangle. So I'm going to call this one an E for equal sides. These are the 2 equal side, and this is the other side or the non-equal side. So I'm going to say N for non-equal. I don't like to use O because that looks like a 0. So again, going back, the first thing I'm going to do is label what everything is. In this case, not like the last one where I said let E equal an equal side, I just drew a picture. It makes it a little bit easier. Okay, the perimeter is 24. So second part is an equation that shows relationship. Well, I know that if I add E plus N, I get 24. So E plus N is 24. Great, got that. That is one relationship. Let's see. The unequal side is twice as long as the equal sides. So the unequal or the non-equal side is twice as long. So this is where I say, okay, are they equal? No. So this does not equal that. Which one's longer? This one's longer. So this one is twice as long as this one. So if I take 2 of those, I get that one. My brain actually has to think it through that way. So And that is my double check. It's like, which one's longer? That one's longer. And that's where you get the problems and make your errors most of the time. So that's what I know. And I now can go on to simplify the equation to have one variable. Well, I'm going to use this equation up top. Usually you can pick either one, but I'm going to pick the one that's kind of obvious. The first one, the equal sign plus an equal sign plus a non-equal side equals 24. So that's equal side plus the non-equal side. Sorry, adjusting my thing. My camera seems to be shaking. I think it must be nervous. Anyway, plus the non-equal side. Well, the non-equal side is equal to twice the equal side. Notice that? So this n, I'm basically substituting this n, or the 2e, into that one, and that's going to equal 24. So this case, I have 4e equals 24. Divide both sides by 4, and I get e is 6. So each equal side is 6. Going back to my side, I know the non-equal side is double that, so that's going to be 12. I now have my triangle. Then I go back to the question. It says, how long are each equal side? Oh, it's 6. Okay, the end. Next question, number 3. And I did all 5 steps. Number 3, Paul is 5 times as old as Sherry, so I'm going to go P equals Paul's age, S equals Sherry's age. Now the problem with S is my S's look like this and my 5s look like this. Sometimes it's really hard to separate them. So if you have S's and 5s issues, make sure you have a nice flat thing and make your S's smaller, or make your S's as like lowercase s or something, but then that looks a little funky. I tend to just be careful and make my S's a little smaller. So anyway, the question is, Paul is 5 times as old as Sherry. Okay, the relationship is Paul and Sherry are not equal. Paul is 5 times Sherry, so it's going to be 5 times Sherry. So Paul is 5 times Sherry's age. It says the sum of their ages, sum means add, so Paul plus Sherry equals 72. So I've now done the equations to show the relationships. Now I'm going to simplify this so I only have one. Since I know Paul is equal to 5s, I'm going to substitute that 5s in there. So I have 5s, that's Paul's age, plus Sherry's age is equal to 72. So that's 6s equals 72. And as you know, 6 times 12 is 72, or divide both sides by 6. 72 divided by 6 is 12. So Sherry is 12. Paul is 5 times that. 5 times 12 is 60. 60 plus 12 is 72. This all works out. That's what I need to know. The question says, how old is Sherry? Okay, check, answer. Solved it. Okay, question number 4. Robert has 3 times the number of oranges as Sam. Together they have 28 oranges. How many oranges does Sam have? Okay, R equals number of oranges for Robert. Seems like a pain to write out that. But if you had a big problem in the future, just getting that habit really makes a difference. And then it also helps you when you get to that last step to track what is what again. What does that stand for? Okay, so, and Sam equals number of oranges as Sam. Okay, so let's see if there's any relationships. It says Robert has 3 times as Sam. So, well, does Robert equal Sam? No. Robert is 3 times Sam. So that means Robert's older. So 3 times Sam is R. 3S equals R. Okay, together they have 28 oranges. That means Robert plus Sam equals 28. Okay, that's fairly clear. Now we have to substitute in, since I know R is equal to 3S, I'm just going to write 3S plus Sam equals 28, or 4S equals 28. 4 times 7 is 28, so S is 7. Sam and Robert is 3 times that, so Robert has got to be 3 times 7, which is 21. So Robert's got 21, Sam's got 27. The question says, how many does Sam have? That's the answer. Okay. All right. Next, new paper. That was so fun. We're going to do it again. Okay. Number 5. Joe and Steve are saving money. Number 5. Okay. So what about them? Let's see if I can adjust this. Hang on. Get a little bit less shadow. Yeah, that's like not even any better. So there. Um, Joe and Steve are saving money. Joe has. Hang on a second. I'm going to adjust this stuff. I'll be right back. Okay, so I'm going to go with number 5 here. Then I'm going to just write down the steps and not talk them through. As I'll go through a little bit faster, so that way you don't have too long. We're already 15 minutes on this. So here we go. Joe and Steve are saving money. So J is Joe's dollars. S equals Steve's dollars. Joe starts with 105, saves $5 a week. So the amount of money Joe has is equal to, W equals the number of weeks. So Joe starts with $105 plus $5 for every week. That's how much Joe's money is. Steve starts with $5 and he saves $15 per week. Okay, it says after how many weeks do they have the same amount of money? So when Joe's money equals Steve's money, that's what we're looking for. And if you notice that, Joe is 105 plus 5W. Steve's has got to be equal to that. Well, that is 5 plus 15W. Notice now I have one solid equation. And so now I'm going to simplify this, subtract 5W from both sides, and I get 10W over here. And then subtract 5 from both sides, and I get 100 over here. And so divide both sides by W, and I get 10 equals, W equals 10. Okay, so 10 weeks. And the question asks how many weeks? And the answer is 10 weeks. Check, done. Number 6. I'm not going to say it. I'm just going to do it. So Mike and Sarah collect rocks. Together they collect 50 rocks. So S, those are my variables, rocks. And M plus S equals 50. Number 7. Now this one's a little different in that boys and girls are not quite equal. I've got 2 choices. I'm going to go ahead and rewrite this one as a boy is equal to, that's a 25, is equal to 25 minus the girls. Because then I can take this B and put it in there. So 2 times the boys, which is 25, minus the girls, plus girls, equals 25. So boys plus girls equals 25. Or 2 boys, sorry. So 2 boys equals 3 girls. Yeah, that's what I'm doing. I'm using this equation. So 2 times the boys, and I know boys are this, equals 3 girls. So that's 50 minus 2g equals 3g. Add 2g to both sides, and I get 5g equals 50. So girls is 10. And so if I want to try and find the boys, it's 25 minus the girls, or 25 minus 10. So the boys is 15. Okay. And that's how many are girls, how many are boys. This question asks how many are girls. All right. Pause. Okay, so here's one we've looked at. Kyle's makes sandals at home. Sandal making tools cost $100. She spent $10 on materials for your sandals. So the cost to making, I'm going to set C is the dollar cost to make sandals. Okay, and I'm going to say P, that's the money he makes, is I'm going to call it the profit or income. Should probably use something else, but I'll use P instead of I because I is hard to work with in equations because I's look like ones if you're not careful. Is the profit. Ultimately, my profit and my cost have to be equal. That's what I'm trying to find. So are they equal? Well, let's see. What are my equations? I say that the cost is going to be $100 plus $10 for, and I'm going to say N is the number of sandals. So $10 for times every sandal he makes, plus the $100 overhead, and that's going to be what it costs him to make sandals. He's selling the sandals, or his profit is he's going to make $30 times every sandal he makes. Okay, so I want these two to be equal. I want the cost to be equal to profits because that's going to be my basic equation. So I have 100 plus 10n equals 30n. Okay, subtract 10n from both sides. I get 100 equals 20n. Divide both sides by 20, and I get n equals 5. Notice I didn't write those things. I just said those things because I can tell from here to here to here what I did. And again, as I talked about in class, how much do you need to write? You need to write enough so that you can go back and check. I can look at this and check just by looking at it what I did from here to here. Subtract 10 from both 30 minus 20. Yes. And then here, divide both sides by 20, and I get 5. Okay. I don't need to write divided minus that. This problem is simple enough for me to just write the equation. So the question is, how many sandals does he need to break even? 5. The end. Question number 9. Okay, Molly's throwing a party. She needs to buy beach towels and beach balls. So I'm going to go T is towels. B is balls. It is beach balls. And towels are 3. Beach balls are 4. She buys 10 items total. So I know that balls plus the towels is 10. I know that we know that the cost of the she buys 10 items total. So that's how many balls, how many towels. I know that if I take $3 times each beach ball plus $4 times every towel, it's going to be a total of $34. That's my second equation here. So I'm looking at um, trying to solve one of those. I have two equations, I have two unknowns, but I can rewrite this first one as b equals 10 minus t, right? Just subtract t from both sides. And so now I can substitute this b for that. So I have 3 times 10 minus t plus 4t equals 34. Okay, multiply 3 times 10 is 30. 3 times negative t is negative 3t plus 4t equals 34. Negative 3t plus 4t is just t. Subtract 30 from both sides, I get 4. 4 towels. And so if there's 4 towels, there's got to be 6 beach balls. So what the question says, how many beach balls? 6. Answer. Okay, number 10. Anna volunteers at a pet shelter. They have dogs and cats. So D is dogs, C is cats. That's pretty easy. There are 36 pets in total. So I have dogs plus cats equals 36. That's first equation. The ratio of dogs to cats is 4 to 5. So 3 dogs is equal to 4 cats. I've got to find dogs and cats. So I'm going to take this first one and I'm going to say dogs are equal to 36 minus cats. Again, I just subtract c from both sides and I get this. So then I can use the second equation, 3 times 36 minus c equals 4c. Multiply it out, 3 times 36 is going to be 108 minus 3c equals 4c. Add um, add 3c to both sides and I get 7c equals 108. So c 108 is going to be 10. 7 times 10 is 70. 7 times 8 is 48. So 18. So there's 18 cats and 18 dogs. Well, let's see. Now, is that right? Well, 7 times. All right, I got to look at that again. 108 divided by 7. 7 goes into 10 times 70. 38 left over. Ooh, mistake. So let's see what the deal is. What I do. Stand by. I'm going to hit pause. I'm going to go back and redo this question. Oops, found the problem. My original question. I know dogs and cats is 30. Going back to here. I was looking at the wrong question. I mixed them up. Okay. Volunteers at a pet show. Dogs and cats are 36 total. The ratio is 4 to 5. I wrote 3 to 4. Duh. So let's try that again. That's 4 dogs equals 5 cats. So going back, I'm going to say 4 times the dogs, which is 36 minus c, is equal to 5 times the cats. So if you mess up one of your original equations, you're in toast. So 4 times 30 is 120. 4 times 6 is 24. So that's 144 minus 4c equals 5c. And add 5c to both sides, or 4c to both sides. I get 9c equals 144. And take your calculator out, or in this case, just do log division if you like doing those. 9 times 10 is 90. Okay, and then I have 54 left. So that's 9 times 10, and I have 54 left over. 9 times, how much is 54? That's right, 9 times 6. So C is 16. And the question is how many cats? So it's 16. Next one. Store sells apples and oranges. Oranges cost $1. Oranges, I'm going to use R for oranges. Why not use, because oranges has an R in it, close enough. Apples, I'm going to use A for apples. Why don't I use O? Because O looks like a 0. So oranges cost 1, apples cost 2. First sale of the day. So oranges plus apples, we sell 15. They made $25. So oranges are $1 each. So 1 times every orange, plus apples are $2 each, 2 times every apple. And you end up with a total of $25. So now I just need to figure out what R and A is. I'm going to go ahead and take this first one and say R is equal to 15 minus A. So I have 15 minus A, that's R, plus 2A equals 25. So negative A plus a positive 2A is just A. So 15 plus A equals 25. Subtract 15 from both sides. A is equal to 10. So there's 10 apples, and that makes sense. If 10 apples plus, so that means R has to be 5. So because 5 plus 10 is 15, 5 plus 2 times 10, or 5 plus 20 is 25. This is right. The question is, how many of each type? Well, 10 apples, 5 oranges. Number 12, last question. Ratio red to green. So R is red, G is green. Marbles. It's 2 to 7. So 2 reds equals 7 greens. 36 marbles in total. R plus G equals 36. So I'm going to substitute R equals 36 minus G. In other words, just subtract G from both sides here. 2 times the red equals 7G. So 2 times 36 is 72. 2 times negative G is negative 2G equals 7G. Add 2G to both sides, I get 9G equals 72. 9 times 8 is 72, so G is 8. There are 8 greens, and I know greens plus red is 36, so that means the red has to be 28. And what's the question? How many red? Tink. The end. Good luck. So work through those so you can follow the process. It's the same 5 steps every time. Talk to you soon.